Hello, this is the Connect team. I'd like to introduce how to create hats using the newly released cap molds and visors. First, a cap mold refers to the base form that defines the overall shape of a hat, while a visor refers to the mold used to create the brim at the front. These two components are key elements that determine the design of a hat. The newly released cap molds and visors are available in both men's and women's versions and support a variety of design styles. For the cap molds, 3 different profiles are provided for men and women respectively, and for the visors, a total of 4 types are available, allowing for various brim curvatures. You can find the download links for the cap molds and visors in the description. Now, let's learn how to make a hat using these newly released cap molds and visors. You can click the link in the description to download the assets for this tutorial from the Connect official store. In this video, we'll be using the commonly used middle profile mold and a half-curved visor. Once you've downloaded them, let's import the middle profile mold into CLAW. When you import the mold, you'll notice the ear dummy. We'll be designing the hat to sit above the ears so that it doesn't pass through the ear dummy. If you're working on a design that covers the ears, right-click above the ear dummy and select Deactivate Avatar to disable it. Then, in the Property Editor, set the opacity to 0 to proceed with the creation. The mold files provided by Connect come with pre-drawn guidelines to make designing easier. You can either use these lines as they are or draw your own if needed. In this video, we'll start by showing you how to draw simple guidelines. First, activate the Show 3D pen and Show Avatar Measure icons from the Avatar Display menu at the top left. This will display all the guidelines needed for hat making. Among these, we'll delete the circumference guideline and redraw it. From the 3D toolbar, select the Edit Measure tool, click on the purple line, and press Delete. Next, select the Edit 3D Pen tool, double-click on the black line to select all of it, and press Delete. Then, select the 3D Avatar Pen tool located under the Edit 3D Pen tool and click a point above the ear dummy. While holding Shift, right-click and drag to rotate the view as you place points around the head. Continue placing points and finally return to the first point to complete the line. This line will serve as a guide for creating the hat pattern. Next, we're going to draw a measuring tape to ensure stable hat pattern construction. On the 3D toolbar, select the basic circumference measure tool. To use this tool, start by clicking once above the ear dummy, then hold Shift and click 2 more times horizontally. This will create the circumference measuring tape. Now, to create a complete crown pattern, we'll finish drawing the remaining design lines. Select the 3D Avatar Pen tool, then press the number 5 on your keyboard to switch to the top view. You'll see a measure tape drawn along the center of the mold. Follow this tape and draw a line using the 3D pen. Then, draw additional lines to divide the crown into 3 equal sections based on the center line. Now let's generate the pattern from the design lines drawn with the 3D Avatar pen. Press and hold the 3D Avatar pen tool, then select the Flatten function. Click on all the surfaces divided by the design lines and press Enter on your keyboard. You'll see that patterns are created in both 3D and 2D views, following the selected shapes. Now, let's adjust the generated pattern to the desired shape. First, in the 2D pattern window, use the Transform Pattern tool to neatly align the patterns in order. Then, select the Edit Style Line tool from the 3D toolbar, to make modifications directly in 3D. When you select a pattern, you'll notice its outline highlighted with a bold solid line. Click and drag the segment you want to modify, and you'll see that the sewn patterns connected to it will adjust accordingly as well. Once you've roughly shaped the pattern in 3D, let's fine-tune it in 2D for more precise detailing. If there are any unnecessary segment points, use the Edit Pattern tool from the 2D toolbar, right-click, and select Convert to Curve Point. Then choose Maintain Curve to turn them into curve points. Next, hold down the Edit Pattern tool to switch to the Edit Curve Point tool. Remove any extra curve points, and adjust the pattern's curves to get the shape you want. Once the pattern modifications are complete, click the Transform Pattern tool in the 2D toolbar and select all patterns in the 2D window. Then, right-click on the pattern and choose Symmetric Pattern with Sewing to duplicate the pattern symmetrically. After duplicating, use the Segment Sewing tool to sew the center, front, and back, where the sewing lines haven't been set yet. Once the patterns have been symmetrically copied, let's adjust a few settings to ensure smooth simulation. First, select the mold and set the skin offset to 0 in the Property Editor window. Next, select all the crown patterns and set the particle distance to 5 and the thickness collision to 1 in the Property Editor. Finally, for a stable simulation, right-click on the patterns and choose Strengthen before running the simulation. Strengthen temporarily makes the selected patterns stiffer, helping them maintain their shape during simulation. Next, we'll create the back opening on the back of the hat using the Internal Line tool. While drawing the back opening line, hold down the Ctrl key to create it as a curve. After drawing the line, use the Edit Curve Point tool to refine it into the desired shape. Once the line is finalized, select the internal line with the Edit Pattern tool, right-click, and choose Cut. Delete the cutout pattern piece afterward. Once the back opening is complete, let's secure the patterns to the mold before working on the inside of the hat. Press and hold the Edit Measure tool in the 3D toolbar and select the Attach to Measure tool. Click the bottom line of each crown pattern, then click the measure tape that was created above the ear. After attaching all patterns to the measure tape, run the simulation. You'll see that the patterns are now fixed along the measure tape line. Now we're going to create the bias tape that goes inside the hat. Before making the bias tape pattern, we need to check the tape length by creating an internal line. The bias tape width will be set to 0.5 inches. Select the outline of the crown pattern, right-click, and choose Offset as internal line to create an internal line at 0.25 inches. Do the same for the rest of the outlines by creating internal lines with the same width. When selecting two segments at the same time, the lines won't intersect. Instead, they'll connect at the crossing points. So, make sure to select each outline individually to create the internal lines. Once all the outlines have internal lines, check in the 3D garment window to see if each internal segment is properly connected and adjust them so they meet correctly. To sew the tape, you'll also need to add additional internal lines between the existing ones to connect them. Since the patterns are symmetric, creating them on one side will automatically generate them on the mirrored side as well. Now let's check the length of the bias tape by clicking on the internal lines. First, we'll measure the bias tape that connects the front and back panel patterns. Select the Edit Pattern tool, hold Shift, and select all the segments that need to be sewn. Then, check the length in the Property Editor window. Now let's create the bias tape pattern using the rectangle tool. After selecting the tool, click on the 2D pattern window and a dialog box will appear. Enter 0.5 inches for the width and 11.82 inches for the height to create the pattern. Use the same method to check the length of the side bias tape and create the corresponding pattern. If you're unsure about where the tape connects, hold Shift and select multiple patterns in the 3D garment window to check their positions. You'll see the corresponding picking points highlighted in the 2D pattern window. Since the side bias tapes are identical on both sides, you only need to make one, sew it, and then copy it as a symmetric pattern. Before sewing the bias tape patterns to the crown, let's add stitch lines to enhance the detail, and then we'll sew along those lines. Assuming the stitch offset is 1/16 inch, select all the long outer segments of the two bias tape patterns, right-click, and choose Offset as Internal Line to create an internal line 0.063 inches away. Do the same for the crown patterns, creating internal lines at the same position. If the internal line is created in the opposite direction, make sure to check Reverse Direction option. Now we're going to sew the bias tape and the crown together. To make sewing easier, turn on Show Arrangement Points from the Avatar Display menu in the upper left corner of the 3D garment window. Then, select the pattern and click the arrangement points to place it. Once placement is complete, use the M to N segment sewing tool to sew the internal lines together. The M to N sewing tool allows you to easily sew M segments to N segments. After sewing all M segments, press Enter, then sew the N segments and press Enter again to finish. For reference, you can set sewing lines in both the 2D and 3D windows. We'll sew the bias tape patterns for the side panels directly in 3D. Once the sewing is complete, we'll proceed to place each pattern. Select each bias tape pattern one by one, right-click, and choose Superimpose Under to place it inside the sewn pattern. To check if it's positioned correctly, turn off the Show Avatar icon in the Avatar display and navigate inside the crown using the 3D view controls. Finally, select the sewn bias tape pattern on the side. Right-click and choose Symmetric Pattern with Sewing to duplicate it symmetrically. When you look at the placed bias tape patterns, you'll notice they overlap. If you run the simulation as is, the patterns will collide with each other. To prevent this, we'll set the pattern layers so they don't collide during simulation. Select the Set Sublayer tool from the 2D Pattern toolbar. Click on the first pattern, and then select the pattern that should be placed underneath it. An arrow with a plus sign in the middle will appear, indicating that the first pattern will be on top and the next selected pattern will be placed underneath. Use this method to set the layers for all the bias tape patterns. Once the layer settings are done, select all the bias tape patterns in the 2D pattern window. In the property editor, set the particle distance to 3 and the thickness collision to 1. Finally, right-click on the patterns in the 3D garment window, choose Strengthen, and run the simulation. Next, let's create the bias tape for the back opening. In actual construction, the back opening is sewn by folding the seam allowance together with the bias tape, so the final length is almost the same as the seam allowance outline length. To replicate this real sewing method, we'll first check the seam allowance outline length by offsetting the pattern. Click the outline of the back opening, right-click, and select Offset Pattern Outlines. Assuming the seam allowance is 0.25 inches, create the offset pattern outline at 0.25 inches. Now check the length of the newly created outline. For one side, it measures 2.08 inches, so the total length of the bias tape will be twice that amount. After checking the outline length, press Ctrl and Z together to undo and return to the pattern without the seam allowance. Now, select the rectangle tool, click on the 2D pattern window, and create the bias tape pattern with a width of 2.08 inches and a height of 0.25 inches. Then, to make it a single completed bias tape pattern, right-click with the Edit Pattern tool and choose Unfold Symmetric Editing with Sewing. Create an internal line on the back opening as well, matching the width of the bias tape. Before sewing the bias tape onto the back opening, we need to separate the areas where the pattern will shrink from the areas where it won't. Usually areas where multiple layers of fabric overlap don't shrink easily. So, for parts where the sweatband and snaps are attached, as well as where the seam allowance and bias tape are sewn, you should do one-to-one sewing. The other areas can shrink naturally during sewing. To achieve this, we'll add segment points to define the exact length for the one-to-one sewing. First, add a point 0.25 inches from the back opening, which matches the width of the bias tape. Since this point is at the intersection of two internal lines, select both internal lines and use the Add Point to Intersection option. This will create 2 points where the lines intersect. Click to delete any points you don't need. Then, to make sewing easier, right-click on the point of the internal line that touches the outline and choose To Pattern Outline under the Extend Trim Add Point options. This will add a segment point right at that spot. Next, let's add segment points at 0.75 inches, where the snap will be sewn on both the outline and the internal line. Press and hold the Edit Pattern tool to select the Add Point Split Line tool. Right-click on the segment, and a pop-up menu will appear. The first option, Split into 2 lines, will already be selected. Set line 1 to 0.75 inches, then click OK. Use the same method to add a point on the internal line as well. Use the same method to add segment points on the bias tape pattern. Then, sew these corresponding segments together using the segment sewing tool. When sewing pattern outlines together, make sure to select the sewing line with the Edit Sewing tool and change the sewing line type to Turned in the Property Editor. Once the sewing is complete, place the pattern using Superimpose under. Just like with the previous bias tape, before running the simulation, set the particle distance to 3 and the thickness collision to 1 in the property editor, then apply strengthen and start the simulation. Now let's make the sweatband that goes on the very inside of the hat. First, to check the total length of the sweatband, hold down the Shift key and select all the bottom segments of half of the crown pattern. The total length comes out to 10.359 inches, so let's click the rectangle tool and create one with a width of 10.36 inches and a height of 1 inch. Just like the back opening bias tape pattern, we're going to use unfold symmetric editing with sewing to turn it into a single finished sweatband pattern. Now let's sew the pattern. Using the M to N free sewing tool, sew the bottom outline of the sweatband to the bottom outline of the crown pattern. Set the bottom segment of the sweatband pattern as M, press Enter, then sew it to each bottom segment of the crown pattern one by one, and press Enter again to finish. And make sure to set the sewing line type to turned. After checking that the sewing looks fine, if there are no issues, select the Superimpose Side option to place it. When you check the placement, you'll see the patterns are slightly overlapping in an unstable way. To stabilize the simulation, select the sweatband pattern and set the layer to -1 in the property editor. Then set the particle distance to 3, thickness collision to 1, and apply strengthen before running the simulation. After the simulation, make sure to set the layer back to 0. In this tutorial video, the sweatband is shown as a single layer. For a more detailed version, you can check out the second cap tutorial video. Next, let's add the snap on top of the hat. We'll create the snap as a pattern. Select the rectangle tool, click in the 2D pattern window, and set the width to 2.75 inches and the height to 0.75 inches to create the pattern. Now, to create the curved edges of the snap, we'll round the corners. Press and hold the Edit Pattern tool and select the Add Point Split Line tool. Right-click on the segment you want to curve and choose the Uniform Split option. This option allows you to divide the segment into a specified number of segments by adding points. Since the default value of number of segments is set to 2, you can add a single segment point in the middle of the segment. After adding the points, press and hold the Edit Pattern tool again, this time selecting the Smooth Curve tool. Click and drag the segment points on the corners to round them out. Round both corners smoothly, adjusting up to the center points. Once the pattern is complete, it's time to place it. In the 3D garment window, turn on Show Arrangement Points from the Avatar display menu in the top left corner. The arrangement points will appear. Select the snap pattern and click the arrangement point located at the back of the hat to place it. Now let's sew the snap pattern between the crown pattern and the sweatband. We'll sew it inward by the width of the bias tape. To do this, we'll create an internal line on the snap pattern that is offset by the width of the bias tape. Right-click on the outline of the snap pattern and select Offset as Internal Line. Set the distance to 0.25 inches and create the internal line. Now we're going to sew, but if you start sewing right from the edge of the crown's outline, it might collide with the sweatband. So, sew from a slightly offset position instead. Use the free sewing tool to set an appropriate position for sewing. If the placement feels a bit off, use the Edit Sewing tool to adjust the sewing line. Before running the simulation, place the snap pattern in the proper position between the crown and sweatband using the gizmo. Then, use the Set Sublayer tool to ensure the snap pattern is positioned outside the sweatband pattern. Now, click on the snap pattern, and in the property editor, set the particle distance to 3 and the thickness collision to 1. After that, turn on strengthen, and then go ahead and run the simulation. Hold down the W key on your keyboard and click the top edge of the snap. You'll see a pink pin appear. With this pin, you can grab it with the gizmo and move the pattern around to fix its position, whether the simulation is on or off. Now select the snap pattern and click Symmetric Pattern to make a mirrored copy. Select the newly created snap on the opposite side and use the gizmo in the 3D garment window to place it in the right spot. Then, just like before, use the Set Sublayer tool to make sure this snap sits outside the sweatband. Once that's all set, turn on Strengthen and run the simulation. Next, let's create the internal shapes, where the snap buttons will be placed. Press and hold the internal polygon line tool and select the internal ellipse tool. Click near the edge of the snap pattern and just keep the default setting for diameter. Then, in the replicate section, set the interval to 0.375 inches and the angle to -90. Finally, set the number of shapes to 6 to generate 6 internal circles in total. To keep these internal shapes in place, use the Tack tool from the 3D toolbar. Select the Tack tool and click each pair of opposing circles to secure them. Finally, let's add the buttons to finish off the snap. Go to the Object Browser in the top right corner and switch to the Button tab. Click Add to create a new button item. In the Property Editor, look to the right of Shape. Here you can choose the button design. For this snap, we're going to use shank button number 6. Then, change the width to 0.21 inches. Next, click the Button tool in the 3D toolbar and place a button on the snap pattern where it needs to go. Click the Select Move Button tool and adjust the button's position in the 2D pattern window. Once you've placed it correctly, right-click on the button and choose Paste. Hold down Shift, drag horizontally to where the next button should be, and right-click again. A dialog box will pop up. Here, keep the interval at 0.5 inches and change the number of buttons to 5. Now you'll see that 5 buttons have been duplicated at equal intervals. Select all the buttons, then in the Property Editor, set the thread length to -0.1. Scroll down, turn collision off, and then run the simulation. If the simulation runs smoothly without any issues, select the snap pattern and set the thickness rendering to 0.5 in the Property Editor. This adjusts the visible thickness of the pattern in 3D for a more realistic look. Then, scroll down to Side Geometry and set the curvature to 20%. This makes the snap's cross-section look much closer to the real thing. Once you've finished making the snap, let's move on to creating the visor. Load the half-curved visor asset that you downloaded from the Connect store. When loading the file, make sure to select Add instead of Open in the Load type, so it gets added to the existing profile mold. Then set the X, Y, and Z axes all to 0, 0. Then you'll see the visor asset load in the correct position where it connects to the crown pattern. Now let's create the visor pattern. Press and hold the 3D pen tool, then click Flatten. After that, click on the visor and press Enter to generate the visor pattern. The visor pattern is created slightly inside the visor, so click the pattern and use the gizmo to move it into the same position as the visor, Then, neatly arrange the visor pattern in the 2D pattern window. Next, let's adjust the curve of the visor pattern that will be sewn to the crown front. Since there are too many segment points, we'll first convert the unnecessary ones into curve points. In the 2D pattern window, use the Edit Pattern tool to select all points on the outline except for the segment points at both ends. Right-click on any selected segment point and choose Convert to Curve Point, then select the Maintain Curve option. Next, press and hold the Edit Pattern tool and select the Add Point Split Line tool. Right-click on the outline and choose the Uniform Split option. Keep the number of segments at the default value of 2 to create a center point on the line. Then, select the Internal Polygon Line tool and, while holding down Shift, draw a vertical internal line. Right-click on the internal line you just created and select Cut. Delete one half of the pattern, then right-click on the center outline using the Edit Pattern tool and select Unfold Symmetric Editing with Sewing to make it a symmetrically editable pattern. Now, let's create an internal line to shape the curve of the visor. Select the Internal Polygon Line tool, place a point 2.7 inches from the center front of the visor, and connect it diagonally to the edge of the visor to create the internal line. Then, press and hold the Edit Pattern tool and select the Edit Curve Point tool to add a curve point and adjust it to get the desired curve shape. Once you're happy with the curve, right-click on the internal line using the Edit Pattern tool and select Cut. Finally, delete the cutoff pattern piece. Now select the visor pattern and set the particle distance to 5 and the thickness collision to 1 in the property editor. Finally, select the visor itself and set the skin offset to 0. Then run the simulation. After the simulation, check the position of the pattern and use the gizmo to place it in the proper position. Once you've finished adjusting the curve of the part of the visor pattern that will be sewn, the next step is to set the final placement angle of the visor. In the 3D garment window, right-click on the visor and select Select Avatar and Garment. This will select only the visor and the visor pattern. Click the visor once more to activate the gizmo. Then use it to rotate the visor and place it at the desired angle. Next, let's sew the visor to the front crown pattern. Since both the crown and the visor are set to be symmetrical, you only need to sew one side, and it will automatically apply to both sides. Select the MN Free Sewing tool and set a single sewing line from the center of the visor to the edge. Press Enter, then start sewing from the center of the crown pattern, setting the sewing line to end at the point that matches the same length, and press Enter again to finish. Right after setting the sewing, go to the Property Editor and set the fold angle to somewhere between 230 and 245. This setting is to enhance the realism of the hat, and the angle may vary depending on the design. For this hat, we'll set it to 235. Once you finish setting the sewing line angle, let's apply 2 more settings to give the visor a more realistic look. Select the visor pattern, then in the Property Editor, set the thickness rendering value to 3. Next, under Side Geometry, set the curvature to 20%. Finally, apply Strengthen to the visor pattern as well, and run the simulation. Now it's time to add some detailed trims to the hat. First, let's apply a top stitch. Go to the object browser in the top right corner and open the Top Stitch tab. Click Add, and you'll see a new item appear called Top Stitch 1. With this item selected, look in the Property Editor for the Offset option. The default is set to 1/16 inch, but click the preset and change it to 0 inch. Next, change the thread thickness. It's set to 40 by default, but bump it up to 100 so it's easier to see. This option controls how thick the top stitch appears. Finally, click the color chip. A color palette will pop up. Just pick black for now so it stands out clearly. Once all the settings are done, let's apply this top stitch item to the crown pattern first. We're going to add the top stitch along the internal lines of the crown pattern where it's sewn to the bias tape. Select the Segment Top Stitch tool from the 2D toolbar and click on the internal lines where you want the top stitch to appear. Next, let's set up the top stitch for the visor. First, we need to create some internal lines where the top stitch will be applied. Right-click on the front outline of the visor and choose Offset as internal line. Set the distance to 0.375 inches and enable both Extend and Maintain Curvature. Once that first internal line is created, right-click on it again and select Offset as internal line. This time, set the number of offsets to 5, the distance to 0.2 inches, and turn Extend off before creating it. Some parts of the additional internal lines are positioned outside the pattern, so select the points on those internal lines and right-click on them. Then, under Extend Trim, choose to Pattern Outline to align the internal lines with the outline of the pattern. Now that all the internal lines for the top stitch have been created, select the Segment Top Stitch tool and apply the top stitch to those internal lines. Since the back opening needs a different offset value, let's add a new top stitch. The basic settings will stay the same, so go to the Top Stitch tab, click on the existing Top Stitch 1 item, and hit Copy. This will duplicate it with all the same settings. Click the duplicated top stitch item, then in the Offset section, click the preset and change it to 1/32 inch. This time, press and hold the Segment Top Stitch tool and select the Free Top Stitch tool. Now, apply the top stitch along the back opening. For the final top stitch detail, let's add eyelets to the center area of the crown. Press and hold the internal polygon line tool and select the internal ellipse tool. Click roughly where the eyelet should go, about 2/5 of the way up the crown. When the dialog box pops up, set the diameter to 0.4 inches. Once the internal ellipse is created, select it with the Transform Pattern tool, right-click, and choose Offset as internal line. Set the number of offsets to 1 and the distance to 0.11 inches to generate an additional inner circle. Double-click the inner circle you just created with the Edit Pattern tool, right-click, and choose Convert to Hole to create the hole. Then, double-click the larger inner circle with the Edit Pattern tool, right-click, and select Clone as Pattern with Sewing to duplicate it as a pattern with sewing lines already set. Next, double-click the hole in the center using the Edit Pattern tool, right-click, and use Copy and Paste to place it in the middle of the duplicated eyelet pattern. Finally, set the sewing lines between the hole in the copied eyelet pattern and the inner circle of the crown's eyelet. Make sure to set the sewing type to turned. Select the eyelet pattern and use the symmetric pattern function to duplicate it. The duplicated pattern will be mirrored with the same sewing lines already applied. Copy the hole you created on the crown and paste it onto the other crown patterns. Then, just like before, create the eyelet pattern using the clone as pattern with sewing option and sew it in place. Once all 6 eyelet patterns have been created, select them all and set the particle distance to 1 and the thickness collision to 1 in the property editor. After that, right-click on the eyelet patterns in the 3D garment window and choose Superimpose over to place them on the outside of the crown. Finally, run the simulation. Now, to make the eyelets look more realistic, we'll use a graphic image in this video. Please just watch this part for reference. Press Y on your keyboard to open the library, then drag and drop the eyelet image into the Fabric tab in the Object Browser. Select the eyelet pattern and apply that fabric. Finally, use the Edit Texture tool from the 2D toolbar to position the graphic properly. Now let's create the top button on the very top of the hat. Go to the Button tab in the Object Browser at the top right corner. Click Add to create a new button item. Select the new button, then in the Property Editor, click the preset under Shape. From the options, choose Shank button number 3. Then, set the width to 0.6 inches and the thickness to 8. Once that's done, select the Button tool from the 3D toolbar and click on the spot where the top button should be placed on the pattern. If you look closely, you'll notice the button is floating slightly above the pattern. Select the Select Move Button tool and click the button. In the Property Editor, set the thread length to -0.22 and turn collision off. Run the simulation, and you'll see the top button properly fixed in place. If the thread length doesn't look quite right, you can adjust it after checking the button's position in the simulation. For the final detail on the hat, let's add a logo graphic. We'll be using a sample graphic image for this, so just follow along for reference. First, click on the Graphics tab in the Object Browser. Then press Y on your keyboard to open the library. Drag and drop the prepared logo graphic into the Graphics tab to add it as an item. Next, let's create a rectangular pattern that will be used as the base for the logo size. Select the Rectangle tool from the 2D toolbar and click in the 2D pattern window. A dialog box will pop up. Enter 2.7 inches for both the width and height to create the rectangular pattern. Finally, drag and drop the logo graphic onto the created rectangular pattern. Right-click on the graphic and select Trace as internal shape. This option converts the shape of the applied graphic into an internal shape on the pattern. Double-click the internal shape with the Edit Pattern tool to select it all, then right-click and choose Cut. Delete the background pattern that gets cut out. Next, select the pattern with the applied graphic and, in the Property Editor, Set the particle distance to 3 and the thickness collision to 1. Since there are too many segment points, use the Edit Pattern tool to drag and select the unnecessary ones. Then, right-click on any segment point and choose Convert to Curve Point, selecting the Maintain Curve option to change it into a curve point. Using this method, change all the points to curve points, leaving only one segment point. Next, press and hold the Edit Pattern tool, select the Add Point Split Line tool, and add a point in the middle of the graphic. Then convert that remaining segment point into a curve point as well. Finally, select the Internal Polygon Line tool, hold Shift, and create a vertical internal line. With the Edit Pattern tool, click the internal line, then right-click and choose to Pattern Outline under the Extend, Trim, and Add Point options. This will add a segment point where the internal line meets the outline, splitting the pattern into 2 segments. Next, use the Trace tool to select only half of the pattern, press Enter, and create an internal line identical to that segment. Double-click the internal line with the Edit Pattern tool to select it, copy it, and paste it onto the crown front, where the graphic will be placed. Then, using the Transform Pattern tool, adjust the internal line on the crown pattern so it aligns with the outline. If any part of the internal line doesn't align perfectly, right-click the points on that internal line with the Edit Pattern tool, select to Pattern Outline under the Extend, Trim, Add Point options, and let it snap to the outline, creating a segment point at the contact. Now, select all the internal lines on the pattern with the applied graphic using the Edit Pattern tool and delete them. Then, use the Segment Sewing tool to sew the pattern. For a more natural graphic appearance, select the sewing line with the Edit Sewing tool, remove the normal map applied to the 3D seam line map, and set both intensity and thickness to 0. Finally, choose the Superimpose Over option to place it on the outside of the crown and run the simulation. Now let's apply fabrics to the finished hat pattern. Press Y on your keyboard to open the library. Click the Fabric tab where you can select preset fabrics provided by Chloe. In the search bar, type twill. Double-click the heavy twill fabric, the first one in the list, to add it to the Fabric tab in the object browser. Next, search for lining. Double-click the polyester satin lining fabric, the second one in the list, to add it to the Fabric tab. Lastly, search for trim. You'll see a hardware material for trims at the top of the list. Double-click it as well to add it to the Fabric tab in the object browser. Since we're using arbitrary fabrics, apply the heavy twill fabric to all patterns except the bias tape, snap, and eyelets. Then, apply the lining fabric to the bias tape and the trim hardware fabric to the snap. Now we've finished everything, from the basic construction of the hat to all the detailed trims. For the final step, let's use the solidify function to keep the hat's current shape while still allowing for natural simulation. Select the visor pattern and in the property editor, turn Solidify On. As I mentioned earlier, this option controls how much of the current simulated shape is maintained. Set the solidify strength of the visor to 80, then select all patterns and set them to unstrengthen. Run the simulation, and you'll see the visor hold its general shape while still bending into a natural angle. And that completes the process of creating a cap using the mold profile and visor provided as Connect assets. Use this tutorial as a reference and try designing your own hat with the cap asset.